Hi class, my name is Daniel. This afternoon I'm going to be presenting to you the physical and chemical properties of matter. My video is broken up into 3 segments today. The first is going to go over just a basic overview of matter. The second will be physical properties, and the third will be chemical properties. So let's begin. First, we'd like to identify what is matter. So I'm matter, this board is matter, even the cell phone taking this video is matter. It's basically anything that takes up space and has mass. What we also need to know is that all matter, living and non-living, are composed of elements that interact with each other to form compounds. Well, that's great. So let's just identify a compound, which are atoms of 2 or more elements chemically united in fixed proportions. Okay, that makes sense. So I've chosen for us today probably one of the most important molecules in the world. We have water. With its 2 hydrogens and 1 oxygen, it's chemically united in this 2-to-1 fixed ratio. Its unique chemical and physical properties allow it to help sustain life on this planet. In the next 2 segments, I will go over exactly that. We'll see you in one moment. Hi class, welcome back. We've arrived to the second segment, the physical properties of matter. So what are physical properties? Well, our book tells us that they can be measured and observed without changing the composition or identity of the substance. So looking at water, in its frozen form and liquid form, it's still H2O. The difference being is that when water is frozen, the hydrogen bonds here actually pull apart, making it less dense. Now, this physical property of water is very important because it helps maintain homeostasis in the Antarctic. If we consider the ocean, for example, if ice was more dense than water, it would sink to the bottom and freeze the ocean from the bottom up. This would destroy the marine life. But luckily, since it floats above the water, it creates an insulating layer for the fishes, gives polar bears and seals a place to hang out. Now, if we take a look at water in its liquid form, we know that the shape of a water molecule and its polarity make hydrogen bonding possible. So what does that mean? Well, hydrogen bonds are really weak. They can break apart and pull back because of water's cohesive ability. That is, its ability to flow freely and move wherever it wants to. Because it's polar, it has an adhesive property, meaning that it can cling to other polar surfaces. Now, these 2 physical properties are essential to biological life on this planet, because without it, plants and humans would not be able to transport nutrients throughout their bodies. In our next segment, chemical properties of matter, we're going to dive a little deeper into this subject. See you in a moment. Hi class, welcome back. We've arrived to the 3rd and final segment, chemical properties of matter. Before we begin, I'd like to do just a quick recap of physical properties. And we remember that those are measurable and observable properties without changing the composition or identity of the substance involved. Now, chemical properties are just the opposite and can only be observed through chemical change. So what we really want to ask ourselves is, how does it react? Well, let's think about water. We know that water is a great solvent. It'll ionize just about anything that's put into it because of its high degree of electronegativity. Remember the negative and positive polar molecules in there? So if we put salt into water, what happens? The salt ionizes and the positive and negative ions line up to the corresponding poles of the water molecule. But water hasn't actually changed. I could reclaim the water if I simply heated it. The water would vaporize and the salt would remain on the bottom of the pan. So this one here is not an example of chemical property. Over here I have biomolecule synthesis. This is a great example of chemical change and chemical properties of water. Now, let's say that we want to store some carbohydrates. Through a dehydration reaction, a water molecule is removed from these corresponding glucose molecules, and we get a disaccharide called maltose and one water molecule. This reaction cannot be brought back through physical means. An opposite reaction, in this case hydrolysis, would have to occur in order to have the water molecule split up the maltose and give us two glucose molecules for quick energy. Water has other types of biomolecule synthesis, but this one I felt was the most easily recognizable. I hope the comparison of the two helped. I also just need to point out that all of the measurable properties fall into two categories. We have your extensive properties, which are additive. So mass, volume, length, and intensive properties, which are non-additive, like density. So a great example, again involving water, would be, imagine if we had a pitcher and two small glasses of water. If we pour the two small glasses into the pitcher, their mass and volume has increased, but the density, its intensive property, has remained the same. So I hope my little talk was able to shed some light, and if you have any questions, please feel free to ask. Thank you very much, and have a great day.